Oh, didn't see you there. Hi, I'm Nadav Wiseman, and today we're going to be learning about box jellyfish and tree diagrams. So, growing up, my biggest fear was box jellyfish, and it turns out box jellyfish is the most deadly sea animal in the entire world. There are two main species of box jellyfish, the first being Chirodropidae, and the second one being Charybdidae. So, out of all of them, the most deadly one is called the Chironex flacari, and that's a Chirodropidae, because you need to know these. So, the box jellyfish's diet consists of two main foods. They eat mantis shrimp, and they eat arrowworms, just like you and me. So let's say that a box jellyfish has a 0.6 probability of eating a mantis shrimp, and it has a 0.3 probability of being a Chirodropidae. So if we're given a set of probability problems with given or complement, it's going to be really difficult to just figure them out off the top of our heads. We need to create a tree diagram. So, the first part of our tree diagram is going to be based on the species. So, let's see, we have 0.3 for the Chirodropidae. Which means we ought to have 0.7 for the Charybdidae. Next, we need to figure out what the diet probabilities will be for each of these given species. So, considering that we are provided with 0.6 for mantis shrimp, 0.6 mantis, we can assume that it's going to be 0.4 for arrowworms. And we're going to do this for the other set of species as well. So our final step in our tree diagram is we want to find the final probabilities of it being, a Chirodropidae and it eating a mantis shrimp, or a Chirodropidae and it eating an arrowfish. So, question is, what is the probability of our box jellyfish eating arrowworms given that its species is Charybdidae? So, the probability of arrowworms, according to our little tree diagram, is 0.4. And because the given is the species Charybdidae, we're going to find our other probability on our little diagram here for it being the Charybdidae species, which it is, yes, 0.7. And so simply divide 0.4 by 0.7, and we're going to get an answer of 0.5714 probability that the jellyfish will eat arrowworms given its species being Charybdidae.
No.
Tell me when.
Action.
So our next sub-question is, what is the probability of our jellyfish eating mantis shrimp or being a Chirodropidae? So for these or questions here, we have to remember the mutually exclusive. In this case, there is an overlap, whereas there is Chirodropidaes that do eat mantis shrimp, and that probability is 0.18, which we derived from our tree diagram. So when we set up this problem, our formula for the OR is, A or B equals probability of A plus the probability of B. And then in this special case where there's the overlap, you subtract it. Subtract A times B. So, filling this in, 0.6 is our probability of it eating a mantis shrimp, and we're going to add that to 0.3, which is our probability of it being a Chirodropidae, and we have to subtract the overlap of 0.18, and that will amount to 0.72. 0.72 probability of the jellyfish eating mantis shrimp. This last sub-question, we're going to be reviewing some more notation. See this little C here? What does this mean? Huh? Complement. That's right. We want to find the probability of our jellyfish being the complement of a Charybdidae. So if the Charybdidae probability is 0.7 that we're given, what's the opposite of it? What's the complement? 0.3, obviously. There we go. 0.3 is the answer to that sub-question. So, my friends, that is the end of today's lesson on jellyfish and tree diagrams. Feel free to ask any jellyfish questions or input any jellyfish comments, because the more we know about these strange, miraculous creatures, the less afraid we can be of them. Thank you.